Hey guys. Hey Donna.
Morning.
Yeah, I'm in San Jose, so it'll be almost like the late afternoon now.
It's 8:30.
Yeah. I made a mistake. I somehow probably the invitation didn't send out, so I don't know like today how many people could join.
Yeah, I think it's gonna be okay. You got people here already.
Yeah. Let's wait for a little bit. I still try to get used to that. I scheduled like 20 meetings, but only today's one stuck in the calendar. So I think it's probably the bug somewhere.
Welcome to calendar in the 2023. I think everyone's bad. I think the best one I've ever used is Google Calendar, and I like it best.
Okay.
It works pretty well.
Mhm. Yeah, I try to figure out how to schedule that recursive one. So I don't want to schedule it on a weekly basis. Somehow it's showing like that. It is a repeated meeting, but it doesn't show up in the calendar, only showing it once. Yeah.
Hmm.
Very interesting. Yeah. Yeah, that's mhm. That's what Jeff is here. I see Rita is here. Yeah.
Hi.
Hey Rita. Yeah. Did the calendar showing up in your side, or because I just realizing that 1 hour ago to see I don't have that in my calendar.
Oh, it does. Actually, last week, you sent the instruction how to basically download the calendar invite, right?
Mhm.
So if we follow that, then it would be recurring, the invitation.
Oh, you got it in the recurring invitation. Somehow I didn't either. I sent out. I don't think I sent out that one. I haven't.
Yeah. I'll forward to you. Yeah.
Okay, I haven't figured out yet because right now in the group like the wiki is still showing one instead of like recursive. If you checking go to the SONiC group, it's only showing today's one. Although I scheduled
that I'm not sure, but it works for me. Yeah.
Oh, that's good.
The iCalendar file seems to be recurring.
Okay. Yeah, if you have the instruction, can you like say send into the group? Then I also try to do it again. Yeah. Okay, so let's probably start it. So it's like 3 minutes already passed. So I see quite a lot of people already here. And today's one, so I asked like Shangshui from Alibaba to give a talk about the SRv6 VPN use case and what's a pain point we are seeing. So then we can see that what's the issues we want to deal with. So that's the main purpose for this meeting. So Shuai, you want to take the ball and sharing, then you can start it.
Okay, wait a minute. Can you see my screen now?
Yes, I do.
I want to do the full screen.
No, now it's a full screen, yeah.
Okay. Let's start. Hello everyone. My name is Shuai. I'm from Alibaba SONiC team. I'm located in China currently, and today I'm going to talk about our SRv6 use case and some challenges or problems when we develop the such kind of feature in our SONiC. And maybe the use case is specified for Alibaba, but we do think some issues or challenges are common for the SONiC. It should be the common issue. So we want to discuss this kind of challenges or problems in the community and make the SONiC to be better or more suitable in some router related scenarios. That's our purpose. Okay. Firstly, I want to introduce a little bit about our routing platform. This is our, we designed this white box by our own self and used in our DCI network. Of course, it uses the software is SONiC based, and we enabled the SRv6 feature for this box to deploy it in the DCI network. And there are something I want to highlight because they are the primary condition for us to develop such kind of features or software. For this box, we use actually, for almost Alibaba's white box, we always choose to use the single silicon. For this box, we choose the single routing silicon to keep the system as simple as possible. And we also use a single routing stack. For the single routing silicon, it means we don't use the chassis-based solution for our white box. We also do not use multi-ASIC architecture in SONiC for our box. We just use a single SoC or single silicon. And so there is no distributed forwarding data plan model in our box because we just use a single SoC. So from the hardware or data path, it's simple. For the single routing stack, it means because it's a single SoC, so there is also no internal BGP peer between internal ASICs. Okay, that's the single SoC. For the single routing stack, it means we only use the IPv4 or IPv6 as the data plan. And for the routings, for the protocol stack, we only use the BGP and no IGP. So this is very important for us because when we extend the SRv6 feature for the FR, we only need to extend it in the BGP, no other IGP protocol. And this is a very brief introduction about our Alibaba physical network. Our box is here. Oh, sorry. In the below, it's our DCN network. We call it, it's our data center network. We call it the DCN. We deployed lots of SONiC-based white box switch on this area. And to connect the different data center or different data center network, we build the DCI network. The code name for us is eCall. And we we enabled the SRv6 feature currently for our DCI network. Our in this DCI network, there are two main rules in this network. The first one is the ESR. It's acting as a PE router, and another one is EC. It's a core router acting as a P router. So our white box is here. The device name is we call it ESR. It's our white box which we just described. So in this network, we enable the SRv6 feature, and in the PE device, we need to do the SRv6 VPN or SRv6 TE or policy feature, and then the EC can also do the SRTE. That's our this is a network diagram where we deploy our white box. And this is a very brief use case for our SRv6 use case. Because in the first phase, we deployed only the SRv6 VPN feature. And in this diagram, this is our ESR device. We call it the ingress device. And this is the egress ESR device on another peer. And from the egress, the control plan is from the egress to ingress. Okay, the data plan is from the ingress to the egress. For a specific tenant, we allocate 4 different WAF for this tenant in the ESR. And in the system, we have multiple tenants. So let's focus on one tenant. Why we allocated the 4 different WAFs? Firstly, this is the default WAF for this tenant. It will receive the service route or customer route from the CE. This is our CE, and in the BGP, we will configure the distribute WAF to other WAF. Then the route will receive from here this WAF and redistribute for another 3 WAF. And of course, in the every 3 WAF will configure the SRv6 locator and with different service seed. So this 3 WAF will export the routes to the VPN v4 and advertise it to the ingress router via the MPBP. So the advertised route will have the different VPN seed for these 3 WAF. They will have the different VPN seed. The action is a DD46. And when the ingress PE receives the routes from this 3 WAF, it will export back the route to the WAF in the ingress device. That's the protocol, the control plan. And after the ingress PE installed the route in the different WAF, the data path from the data path, the ingress PE will encapsulate the user traffic. It could be the IPv4 or IPv6 user traffic. It will encapsulate, when the traffic go into the WAF, it will encapsulate the SRv6 seed. We call it the NI seed. And we will do, in this stage, we will do the traffic engineering traffic engineering, it means TE only in the EC. So after the traffic engineer and the traffic arrived on the egress PE, the egress PE will decap the SRv6 seed because the action is DD46, so it can go into different WAF and then go to the C device. Because we have 3 different WAF, every of them represent different service. We use them for the different SLA. So different seed, different WAF means different VPN seed. Different VPN seed means different service. We do the TE based on service seed on the EC. And maybe in very near future, we will enable the TE. The TE will initial at the ESR also. So after that, the ESR or SONiC will also support will also need to support the SR policy on the PE side, and then we don't need to do the TE on the core. For the data paths, we have 2 different methods to let the customer traffic go into different WAF. It means this customer maybe want to go to this LSA, maybe go to this LSA. We have 2 different methods. The first method is that if the packet is a standard IPv4 or IPv6 packet, we can use the DSCP and then use ACL to do the PBR to direct the traffic into different service WAF. And another method is if the client have the ability for the SRv6, may need encap the UI SRv6 seed on the customer side. It means the customer side may have the ability to choose the different service. The method is to use a different seed, and on this device we will decap this UI seed and similarly go to the specific WAF and with different NI seed. The NI seed will decide the service on this network. When we develop this kind of features, we meet some challenges or problems. The first one is the communication channel between the FR and the kernel and SONiC. Because currently the FR use the SONiC and also the Linux as a data plan. From the FR to Linux, it used the netlink, and for the FR to SONiC, it also use the netlink message format, both for the IPM or data plan IPM. But we meet some issues that in some of cases, the Linux did not support this kind of features, this kind of use case, or maybe Linux or netlink may support them in future, or maybe they will never support that. For example, the service route I just described, currently we need to configure the route with extended VPN seed. The Linux currently did not support, the Linux data path did not support the VPN seed. So of course there is no define in the netlink. So we cannot configure the route to the SONiC because the SONiC also use a netlink format. And for some other use case or scenarios, for example, SR policy is totally different with the route. It's not the route, not the neighbor, not the next hop. It's totally a different kind of table. And we also need to configure the BFD session from FR BFDD into the SONiC. The key for the BFD session is also not the defined by the netlink, and I think maybe Linux will never support the BFD format in the netlink because kernel is software, BFD is also software. It doesn't make sense to offload the BFD into the kernel, but in the SONiC data path, we do need that. So, so currently we meet this problem is that for the BFD, we also need to receive the FR also need able to receive the notification for the BFD sessions. It means the BFD status. And so to summarize, we for the FR and so for the communication channel between the FR and the SONiC, we need the bidirectional communication because we also need to receive the notification. And the most important one is that we need arbitrary message format, but currently the IPM or FEM data path use a netlink. For example, the SR policy or BFD session is not supported by the netlink format, but we do need FR to install such kind of tables into the SONiC. And another similar issue is that the Linux kernel currently do not support the SRv6 forwarding chain with VPN seed. Actually, this is not the issue for FR or SONiC community. We just state our problem here. Maybe someone else have a similar issue too. Because the Linux kernel cannot forward such kind of SRv6 packets with VPN seed. So there are some issues we meet because, for example, we need to ping or response the ping for this route. But this route in the Linux kernel or in the data path may do need the VPN seed, but the Linux kernel did not support this kind of forwarding. So we cannot do the ping or response ping in the Linux. That's a problem for us. And another one is that because we use the BFD in the FR, so FR BFD also depends on the Linux as a data path to forward this kind of BFD packets. And we also need the FR to software to establish the session. After the session is established, then we will offload into the SONiC. So we have to use FR BFD daemon. But if this BFD session need to go through the SRv6 data plan, but the Linux, because the Linux did not support this kind of forwarding, so it's hard to forward the BFD packets from the FR BFDD. Another use case that because currently the SONiC VM data path totally depend on the Linux forwarding. So with the SRv6 case, we cannot support the SONiC VM data path for SRv6. Another challenge is for the routing loading time, because in our system, our requirement is for the FIB is very huge. The requirement is above 2 million FIBs because we will duplicate the service route to 4 different WAFs. So our requirement for the FIB is very high. So after the test, the per system routing loading time, the per system is less than 10K per second. We already enabled the route block operations in the SONiC. This number is not good, and we do some analysis. Firstly, we do some tests on the vendor side. and the vendor side can support more faster than this number. And we also do another test on the FR side. FR, the Zebra or BGP is quite faster. So the controller also has no issue. It can, the routing load time in the FR is quite faster than this number. So we found the current, the bottleneck, the performance bottleneck is the OC agent, because all the OC agent use a single thread to process the message from the FDB into ASIC DB. It's used a single thread, so it's not quite high performance. So currently, this is the flame diagram for graph for when we do the simple analysis for the OC agent. I want to highlight that currently the routing loading time bottleneck is on the OC agent. And because we need to support mass BGP paths and feed number, so another problem is about the memory. Initially, our system has 16 gigabyte DDR memory, and we found in our test we found it's not enough for the 2 million feed. The first there are 3 main process used almost all the memory. The first one is FR, the BGP demo. It used almost half memory of the system, because the BGP path is much higher than the 2 million. And another process which used huge memory is the OC agent. And another one is the SONiC. The SONiC, the main usage for the SONiC is the vendor side. So in our environment, SONiC, totally the SONiC used too much memory. Then we have to increase our physical DDR memory in our system. And we do some analysis. Firstly, is from the FR side, because we use the SRv6 route. In the FR, this data structure will use many means this data structure will use 384 byte per BGP path, because the BGP path is huge, so the BGP will use a lot of memory. So we just do some reduction the memory method. Firstly, we just simple to disable some unused feature in the BGP. For example, we just disable the VNC feature when we build the BGP, because we don't need this feature in our use case. So we can just disable that. It can save some memory. And we also do some optimization for the BGP path extra and remove the seed variable. Remove the seed variable from this data structure and use it when we need to use the seed. We use another data structure. After that, we can reduce the size of this structure from 300, almost 400 byte to almost 100 byte. It saved a lot of memory for the BGP path. And from the OC agent side, we found the SIMATA used many of the memory, because you know the FIB is 2 million. So the SIMATA used many memories. And in the original test, we found the Awk agent used almost 3.3 gig memory with 2 million routes. And because the SciMat just used to store and validate Sci object in this data structure, so we just did a simple modification. It's not good, but we must reduce the memory to move the project forward. So we just bypass the SciMat for the route entry. For some other Sci object is the same, is regular, but we just bypass the SciMat for the route entry. We can save almost half memories for the occasion. So summarize totally the SONiC, including the FR in our system originally used too much memory comparing with a commercial device. And another challenge or issue we meet is this is a scenario. We found the underlay route flap may affect the overlay SRv6 route. And this is a very brief example in the FR. This is the output from the FR. This is our service route for the IPv4 or IPv6. And this is the nest hop for the service route or SRv6 route. And this is VPN seed. The VPN seed is not related with this problem. And for the nest hop, the Zebra need to recursive resolve it to another nest hops. And this is a underlay route in the system. So if in the test we flap the underlay route, for example, we flap it from the nest hop A and B to from a ECMP to a single nest hop A. It means we flap the underlay route. After this change, from the FR or Zebra side, the service route will look like this. This is also the same service route. This is the nest hop for this route. From the service route point of view, there is no any changes, but the underlay route Zebra will recursively resolve to another nest hop. That's a change. So from the FR side is totally correct, but from the data plan, the SONiC data plan or most of the chip data paths is not. It's a difference because in the chip data paths, the overlay route is totally independent with the underlay route. For example, when we do have many millions of overlay route, they may point to single underlay route. So when in the data paths, when the underlay route flap, we don't expect it will affect the overlay route. But in current implementation, in this case, the BGP in the FR side, the BGP will send millions of overlay route to notify Zebra to resolve the new underlay nest hop, but it did not use. But in the SONiC data path or chip data path, we don't need that. And another issue is that Zebra will also notify the SONiC millions of such kind of update. But for the data path, there is no any change for the overlay SRv6 route. So we meet two critical issues in our test. The first one is because there are too many messages. If we always flap this single underlay route. We found sometimes there is condition the zebra cannot resolve the net hop for the overlay, and it cannot recover forever. And another issue is because zebra will also notify the SONiC, so there are millions of overlay route from the zebra to SONiC, and the zebra will also notify the SONiC the single underlay route to update. So the SONiC will, the underlay update is important for the data plan, and it only have one entry, but it will be blocked by millions of other overlay routes. It's not necessary for the SONiC database data path. And I think this is a final issue we meet. This is a very common use case for the SRv6 policy. And in the data path, we need, for example, this one is a route of fib, and it may have different SR policy. So this is a ECMP for the policy, and every policy may have a different seed list. So policy is a list of list. So this is kind of another level ECMP. And after the SRv6 encapsulation in the data path, it do need to look up the underlay for this packets. So there are another level ECMP for the underlay net hop. So totally in the data path, we do need the 3-level ECMP, and logically in the control plan or in the upper software, we need to support the 2-level ECMP at least. But in the data plan, we need to support 3-level ECMP. But currently, the data paths, many of the data paths do not support the 3-level. Many of them support only 2-level or at most for the hierarchy ECMP. And another issue in the software is that the Orca agent do not support currently we think the Orca agent do not support the multi-level ECMP. So we cannot support this 2-level ECMP in the Orca agent. So we have to do some complex modification in the code to flatten the overlay from ECMP from 2-level into single level. The reason is the data path and also the Orca agent currently. Yeah. This is okay. This is the final issues we met. That's all. And yeah.
Good. Thanks, Shuai. Yeah. So, any questions? I think this is basically describe what the challenges that we are facing, and there are a lot of these issues. That's why we schedule these working groups. So I think some of them where we have a lot of commonality of other use cases also.
I think Eddie, this is, sorry, go ahead.
So for the BFD integration into the data plane, is there any particular reason why you've decided that it has to go down through Zebra?
Do you mean why we configure the BFD in the data path, only in the data path, right? Not the Zebra?
You had a slide that talked about BFD.
Yeah.
And how it needs to be used the netlink, which kind of implies it's going to go through Zebra.
Okay.
And I actually kind of disagree with that assertion. There's already code, I believe, in BFD itself the BFD daemon itself to talk to a data plane?
I don't think so. Actually,
yeah, I think there is Sharp, right? At least FRR, I mean, BFD, I believe supports it. The other thing I was also going to mention, Eddie and team on this one, we might be good to follow up is there's also a BFD hardware offload mechanism that's, some of that exists and some of that is actually getting added, where you can use a hardware offloaded BFD. No, I understand most of the ASICs I think that are coming up do support this. So I understand there might be a platform level dependency here, but I believe there is support that is getting added to have a hardware offloaded BFD to be able to use that to kind of track the BFD sessions in FRR. So kind of tie the hardware offloaded aspect of FRR BFD to that. So one of the follow-ups, it might be good to kind of explore that option, especially for this. In general, one comment I wanted to make, Eddie, is I think it'll be, I mean, this is a good overview. Thanks for doing this. I think what would also help is to kind of prioritize these and within this group in terms of like, how do we want to, what sequence we want to address these problems from an overall community standpoint. And that would be a good follow-up to have.
Mm-hmm. I think for the BFD, that discussion, we probably can go deeper because my understanding is like, say, because your hardware, everything comes from the SYNC-D, which is sitting in the SONiC code. But the BFD, the state eventually will need to be consumed by the various protocol like the BGP or like say like this time the SR and the policy. That's why I don't know that how we can bridging them together if today we don't even have the callback channel from the SONiC back to the FRR. So
yeah, someone needs to write it, right? But I'm just questioning whether it needs to go through Zebra. I don't think it should go through Zebra, is what I'm saying.
Oh, okay, okay.
And maybe this falls into your, maybe this falls into one of your suggestions about creating a two-way communication or better two-way communication.
Yes.
And the
SONiC and FRR in general.
Yeah,
I have a question for Donald here.
Not necessarily going to the Zebra, but we definitely need from a callback, but then we need to design it to see how we design this callback because there are two parts.
Like I said, there's already a mechanism, I believe, in BFD already that allows it to talk to a data plane in some manner.
Are you referring to PTM?
No, I am not referring to PTM. PTM is a Cumulus thing. Is not the BFD. So the history here is that BFD was originally implemented to through a Cumulus offload through the PTMD, and then probably 2 or 3 years back, Renato Westphal wrote a standalone BFD daemon. No, I'm sorry, it was Raphael, not Renato, and basically, he implemented the BFD protocol directly in FRR itself.
Mm-hmm.
And then I believe in the last year or so, there was some work that was also done where we accepted the start of the abstraction of the BFD daemon so it could allow itself to talk to a data plane for the BFD protocol offload into the data plane directly. And all I'm saying is that's the direction the community is going.
Okay.
And if you go a different direction, we're going to go, why?
Mm-hmm. Mm-hmm.
So just be aware of that, and look into that. And that's why, and if there isn't the communication channel you want, it belongs in BFD from my perspective.
That's fine. Yeah, I agree. Like I say, jumping from the Zebra, which is the middleman, doesn't make the communication.
Yeah.
efficient.
So one of the long-term things that we've been kind of playing around with, I don't think there's any set plans, but Zebra, you're right. Zebra is the middleman for everyone, but I don't think it needs to be the middleman for everything. Like I think BGP should be able to open up the channel to BFD to get the data directly, the ZAPI message directly from BFD instead of going through Zebra. Someone needs to write that. There's talk, and this would extend to things like layer two connectivity, like, BGP with EVPN creates neighbor entries, but it really probably shouldn't be passing through Zebra. We need to have a daemon that controls neighbor entries and handles that appropriately.
Donald, how's registration from FRR BFD happening today? How is next hop and validation? I would assume it's done through Zebra, right?
It's done through, you talk through Zebra, yeah.
Yeah.
And I insisted on that because I wanted the backwards compatibility for PTMD. If I didn't need that for Cumulus Linux, I wouldn't have gone down that little slightly hiccup, but I think the long-term goal is that if I want to talk to BFD, I should talk to BFD. I'm not so sure that I would go that, like directly let maybe BGP talk to OSPF or BGP talk to RIP or something like that, or EIGRP. I don't know if we go that far yet, but I think, for core services, you need to talk to the appropriate daemon. Just someone needs to go in and do it.
Mm-hmm. So you are saying, maybe for forwarding related, let's still using the Zebra as a mean, because the Zebra anyway have all the intelligence for the routes. He need to resolving the routes, so let's don't touching it. But for those like a service type of the service like a BFD, those things we can just go directly.
Yeah, and like in layer two, like neighbor entries and managing all that too, and managing bridges and being able to configure them, that all should probably be in its own, not in Zebra necessarily, but it should be in an L2 daemon. And I know people are working on that right now.
I kind of agree with you because
yes,
you feel like they let the Zebra become the communication channel, defeat the whole purpose to let the whole Zebra idea is a RIP.
Exactly.
Yeah, but this is traditional implementation, right?
Yeah.
This is, you would do it in RIP.
Okay.
I see Donald's side, but practically RIP is a sub-pub infrastructure to invalidate next hop for everybody when BFD changes its state. So changing it to something else would require significant departure from what we used to.
Yeah, that's true, Jeff. That's why I would say for forwarding related, let's still stick it with the Zebra because that's a RIP, that's the brain part. But for say the BFD, the other link up and down, also the neighbor, these things, you give it to the Zebra cannot handle it. He still need to be the off-handed back to the BFD. So then it just becomes the middleman. If the middleman, I kind of agree with Donna to say, why just communication directly?
So Donald, this BFD offload, has these changes already happened in the FRR any version, or these are planned?
I think some work has been done there, and I would recommend going pulling master and looking at it. I sorry, someone's an Amber Alert. I think people have done some work there, and we've accepted some code. And I don't know off the top of my head.
Okay.
Okay, so
pull
the idea is
master
that the same,
and look at the BFD commits.
Sure. Okay.
The second thing I wanted to talk a little bit about, can you pull the slide up where you talked about the BGP memory again?
Okay.
Yeah.
I kind of disagreed with the approach taken to some extent. I wanted to point out the way that we've been talking about in the community that we want to solve the problem.
Mm-hmm.
Here we go. So the BGP path info extra, right? So if you are not running EVPN, you are paying the price for EVPN and the BGP path info extra. So what we wanted to do was create an abstraction to allow you to ask the path info extra for, I need SRv6 data, and it'll create a pointer and hand it back to you so you can use it appropriately. And it wouldn't allocate memory unless you needed it. Or I need VNC data, And so all these, V and C, you're right, is a pretty big chunk of the path info extra. But and if you're looking at 8.2 path info extra, if you look at, if you look at master, it's over 400 bytes now because of people have added more stuff. But if you really need to reduce the size of the ancillary, let's go down the path where the community's kind of decided about abstracting out the ability to ask for that data only when it's, and only create the memory for it when it was needed. Like if I'm doing a SRV, if I'm doing SRV6 and I'm not doing EVPN, I shouldn't be locating the EVPN data structure for that particular path, that path info extra. So I would encourage you to think about it from that perspective. I don't know, just moving something into the MP info, I don't know that's the right place to put it.
Sure. It's just a workaround.
Yeah, actually, there's one other way. Go to the next slide. I was thinking about this as well. If you're really interested in memory, you did you did show IP route, and we've got all this BGP data. If you don't need that BGP data in Zebra, you can reduce the amount of memory being passed down significantly by turning that off. So like the AS path is being listed there, right? And a whole bunch of extra data. So you can turn that off. I don't know if you're aware of that. And that would reduce your memory footprint. We pass down communities as well as AS path, and I think there's a couple other things we pass down as well. But you can turn that off.
But that other one for the because normally the vendors the show IP route has it.
Yeah, and I added this feature. So I know, and I added this feature, which is why I'm saying you can turn it off if you're not using it, or if you're using it, that's fine. But just be aware that that's cost of memory, because what's happening is that BGP is passing down the actual AS path string to Zebra, and Zebra has to store it somehow. Mm-hmm. And BGP is passing down the list of communities that Zebra has to store somehow or another. So it's duplicated data. And yeah, I realize that it's actually probably really useful, which is why I added it. But if you're really, really concerned about memory, you can turn that off and save yourself some Zebra size.
I think that one I probably will keep for now, because that's introducing the debuggability. That is kind of like I say, everybody has it and run for debug.
Yeah, and that's exactly why I added it, because it provides a lot of useful information.
But I think that your previous suggestion, like I say, we will not allocate the space unless this feature is enabled. Just like here, we if we using only the SRV6, we should not using EVPN to allocate any byte for that.
And maybe the way, when you allocate the BGP path info, when you're allocating the ancillary route info, you know what you've configured for, I'm passing SRV6 data in this guy, so I need to create the SRV6 pointer, and I can use that automatically. There's some intelligence there, right? Because when you create the ancillary route info, you know what pointers you need.
Yes.
But that's what I would suggest, going down that route and abstracting that,
So it looks like, some of these optimizations that Donald you're referring to, they came in later versions of FRR, right? Because if I remember, all of this, even like 6 labels or 12 labels, SRV6 actually were embedded into the path attribute, and that was actually bloating the memory. Yes. Ideally, those should have been actually allocated on demand.
I agree. Yeah. So today we need to come up with the solution. I just showing the problems. Like Praveen suggested, we probably need to tackle down, put the priority and tackle down one by one. Yeah.
No, I'm still not very clear on this. On Donald's point that, well, as per Donald, what he is saying is that this is not a problem, because the allocation is already happening based on the type of route.
No, I didn't say that. I said someone needs to do it.
Oh, okay, got it.
For the BGP path info extra, someone needs to do that work.
Correct. Yeah, got it.
Agree. Mm-hmm.
And all I was really trying to say, to reiterate, is that if you're going to go down the path of trying to save memory, let's do it in a way that is acceptable, that you won't have to maintain the code. Because I can guarantee you, if someone submits a change to move the SID from the BGP path info extra and put it in the NPM info, it's going to be a non-starter. It's going to inaccurate, and then you'll have to carry that patch yourself.
Yeah.
Good. I think that's a good.
For the next hop, I think this was good. For the next hop, the issue of overlay route being modified.
No, underlay route modified will be triggered overlay flashing.
Correct. So BGP need to know whether the underlay next hop is actually reachable, and that's why it is subscribing. But then it just needs to know whether the route is reachable or not. It does not need to know when the path of the underlay route changes. So because of this duplicate or unwanted information that is coming to BGP is reinstalling the route again and again, even if the actual next hop does not change.
I think this is for the global table, because the Linux doesn't support the recursive, so we have always resolving it. There's no recursive for the global table as of today. I think that's why, like I say, once you have a 2 pass to 1 pass changing, you have to go through the whole BGP. That BGP flash.
No, the Zebra already takes care of it, right? You don't have to reinstall the route from BGP.
No, I think like we run the BGP to refreshing, then the BGP routes can be resolving from the because there's no recursive there for the global table.
Okay, so you're saying this is specific to SRv6?
No. What I mean is like this behavior is specific initially for the global table, but we take the hit because SRv6, this is like I say, this is the v4 routes, but the next hop never been changed in this scenario. So we supposed to not necessary to be flushing. But
yeah,
this behavior was initially the global table behavior. Say, for example, you have like say global table, the v4 over v4 case. Then the Linux kernel only have a flattened table. There's no recursive there. So then you rely on the BGP refreshing to resolving from basically now you need to make it the open, like I say, the recursive routes to be pointing to the underlay next hop again. So you don't have a recursive BGP next hop. That's why you rely on the BGP to refreshing the whole routes, and then you can re-resolving it.
Yeah, this is what I'm trying to say, that the recursive next hop resolution is automatically done by Zebra. You don't have to reinstall the route. I'm not sure whether this is required for the SRv6 specifically, but if you look at, say, VRF or VXLAN, at least that is not the case.
But this is the behavior we see that currently Zebra always inform, like I say,
Yes,
even
correct.
I remember
correct.
the reason for that is because of the global table routes needed. That's why the Zebra always refreshing the BGP as of today. But for VPN routes, I agree with you because we are even in two different tables. So there's really no need of refreshing. Nothing changed.
Correct. So what I'm trying to say here is that the optimization is needed in BGP, where it should not look at the path changes, but it should just look at whether the next hop has gone from, say, 0 path to non-zero path or non-zero path to 0 path. And that should be the only trigger to reinstall the route to Zebra. Otherwise, it should not react.
Yeah, we can discuss how we fixing those issues later on. We only have 2 more minutes left. Yeah.
Sure. Yeah, but I think it's I would say, most of the folks have here would have came across the same kind of problems here and there. And yeah, it's a good summary, I would say.
Yeah, that's good. Yeah. for the next week, Hassan, you will be able to give us the talk about the Broadcom work for the Linux routing enhancement.
Yeah, I mean, my observation were also somewhat aligned to some of these, but not in SRv6 area, but I would say it was
Maybe.
overall, yeah. So we can talk about that, and we can pick up some of these topics as well for discussion.
That'd be great. So maybe next week you can talk about that. Then after that, I think Gongjian from the Alibaba, we probably want to like give one proposal to see based on like today's Donna's suggestion. I was saying like from my point of view, the first priority will basically say, can we get in the communication channel to be resolved, because that will be solving quite a lot of problems. Yeah. Okay, so that's pretty much all for today. Any other comments before we closing this meeting? Good. Then I will see everyone next week. So then Hassan will give us the discussion on what is the enhancement he made from the Broadcom point of view. Yeah. Good.
Thanks, everyone.
Okay, thanks. Okay, bye.
Thank you. Thank you. Bye-bye.